let's take a look at a couple more of these styles of log equations, guys. Okay. So what's happening now is I'm just going to show you guys about, I think there's about 3 more types of these examples to go over. And like I said, I'll give you guys some time to continue working on it in class, and then we'll finish the equations today, and then next week we're going to do 2 sections of modeling. And like I said in the past, when we've done the modeling, remember how we were able to write functions given points and things like that? We were able to write the equations of the parabola given 2 points. You're able to write the cubic function. It's basically the same idea, where there's a standard formula to follow and go from there. So we'll have 2 sections of modeling to look at. We might even be able to get both of those done in the same day, and then we'll be able to answer up a little bit extra questions via Tuesday and Wednesday, and then we'll just keep that test going for Thursday. Sound like a plan?
Sounds like a plan.
All right. So in this one here, we're talking about a log equation. Notice we have logs on both sides. Do they have the same base? What do?
You destroy.
You just drop them. You destroy them? Yes. Kablamo! And you get 5x minus 1 equals x plus 7. Again, what we're doing here is we're basically just getting rid of it. Since they're the same base, it works. It has to work. It has to be equal. Again, this should be happy math. It looks really weird, but yet it's not that bad. And again, what should you be doing to verify that your answers are correct? Because every once in a while you're going to get an oddball. What's that? Circling it.
Yeah, because verified choice.
Oh, verified choice. Never thought of it that way. That's good. That's very good. All right. All right, do this one. Log base 2 of x plus 2 equals log base 2 of x squared. They the same base? Okay.
You know it's 2.
It's 2 and negative 1.
Again, set aside equal to 0.
Oh my god.
It's not get safe.
Bring this over.
It's not an educated guess.
You guys absolutely killed me. You know that? What do you have to do then? Verify it. That is the greatest answer I've ever heard on one of those things. I've never thought of it that way. But you're right. That is the cheesy way of saying it, but that is correct. What do you have to do, guys? Substitute it and check to see if it works. Does 2 work?
Yeah.
Okay, does negative 1 work?
Yes.
Yes. So can you just jump right away and say the answer is going to be 2?
No.
No.
It was right.
You were half right.
That's still partially right.
Again, guys, there will be times, just like we've had in the past, whenever we had a factoring problem, both results may work, one result may work, or neither result may work. Verify it, okay? Just double check. Okay. I don't think we need to do this. No, we don't. All right. Again, I don't need to go over all the words here. What do I have to do
log 5, which is 2, and then that's like, it drops down.
Careful. Think about your properties, guys. Think about the properties of logarithms.
Couldn't you
Log base b of b to the x is x, right? I mean 1. Okay. And what about b to the log base b of x? What does that equal to? What do I have to do here? I have to exponentiate it. This one's a little bit different. In order to get rid of this log here, this log has to become an exponent. Like that. Now that that log became the exponent, what happens to the 3x plus 1? It drops. So it becomes 3x plus 1 is equal to, what is it, 5 squared is, shush.
It's okay, it's right.
For some odd reason, I was thinking it was 2 to the 5th. And I'm like, that's not right. It's not 32. And then you solve it out of that. You get 8. You okay on that? Again, when you only have a singular log, that's usually when you're going to have to use. You have to use your exponentiate. I don't think that's a word. It might be. I may be making that up. I don't know.
I thought in the book it said exponentiate.
Oh, cool. Then I was paying attention. All right, try this one.
Negative x equals negative squared.
I think he might be overthinking it, though. I don't know. I haven't done the problem yet. All I did was write it in here. What do you have to exponentiate? What are you going to use? Good. What's 2 to the negative 1? 1/2.
You told me that wasn't the answer.
Well, I didn't know. You said negative 1 squared.
That's backwards.
Okay. Let's see what happens now. Let's see what happens now. Of course.
Are you reading?
What's that?
256.
What's the answer? I don't know.
I'm sorry, I didn't.
What do we do first, guys?
Exponentiate.
No. What do we do first? Subtract 15.
Now, do you divide by 2 after that? Or no?
What do you think?
I would say.
I agree.
That's what I did. Okay. I was just thinking you might have to rewrite it.
And now what do you do?
82? Okay, yeah.
Put everything up.
32, 64, 128, 256. I was halfway there. Get it?
I got the right answer. You told me you didn't do it yet.
Yes, ma'am. I think the non-calculator parts give you the graph. Okay. Waiting. 2 to the 8th power.
Oh, okay. I was thinking squared.
Yeah, and a lot of times you'll think that right away. Just remember, it's because you exponentiate, it's 2 raised to that power. In your mind, you're always thinking that you're squaring it. we're used to be working with square roots, not logarithms. That was too easy. Too easy. Again, what happens when you have multiple logs on one side? When you have multiple logs on one side,
Make 1 equal to 0.
yeah, you have to condense it first. You have to condense it prior to working with it. Again, if you have more than one log on a side of an equation, you have to condense it to have a single log to make it work. So in this case here, if I have an addition, what does that mean between the two parts? We're multiplying. Does everybody agree? So if I condense the left-hand side, I'm going to get log of 5x times x minus 1 is 2. Does everybody agree to that? Okay. Now there's one of two things we can do right away. I could distribute that if I want, or what am I going to have to do in order to get rid of that log anyway? Exponentiate it by 10. If I raise this up here, now I'm going to be left with 5x squared minus 5x is 100. Does everybody agree with that? Yeah. What I did is I just combined a couple of steps at once. Again, I'm back to a factoring problem. I got to set aside equal to 0. Good, I heard someone say that. What's the first rule of factoring?
Least common factor.
Greatest common factor. You're close.
I was close. Give me credit.
You get x squared minus x minus 20. What times what's negative 20? You add the other, you get negative 1? Which one's which?
Negative 4.
So your zeros would be at 5 or negative 4. Now, again, what do you have to do with those values? Substitute. We're not doing electrical work. We're not part of the IDEW, International Brotherhood of Electrical Workers.
That's a thing?
That's actually electrical union, you know?
Yes.
Why can't they just say electrical?
Yeah, you should. Duh. Yeah, bro. Bro. Again, when you check these things, you might find out that one of them works or the other one does not work. For example, can I take a log of a negative? Did it work? 5 works. Okay. So what do you do to verify again the solder way? You circle it.
Wait.
That works.
I missed that.
He made a joke earlier that I thought was quite witty. I said, how do you verify your answers? He said, circle them.
So that's it.
But in essence, remember, you're substituting back in to see which one works.
I'm pretty
Okay?
good too.
Why can't
Yeah.
you log an extra number?
That explains a lot of that.
So you're asking yourself in a logarithm. Log of what base? We discussed that too. Let me give you some problems. One thing, there's a couple of problems on here that I'm giving you guys that use some of the old equations from exponential growth and exponential decay from sections 8.1 and 8.2. I think there's even a PERT problem. So 8.1, 8.2, and 8.3. Guys, come on. When we did those exponential growth and decay problems, we were basically figuring out the answer. Now, one of these variables might be, well, you have to use one of these exponent rules log rules to get it. You would be solving for the variables. You just have to go back and remember which equation you're working with. So on 506, it's the same section. So this is what, 8.6. Numbers 43 to 57. Don't do 51 or 52. And then 63, 64, and 65. And we'll call it a day on these things. Now, one thing I will tell you is that there's a natural log problem in there, or two. How do you undo a natural log? You E it. Yeah. All right. All right. So again, we're going to test out of this stuff next Thursday. We've got 2 days left of modeling stuff to look at and go from there. Question has come up for those of you guys that were using the website as far as not bookmarking the actual Google site. I did have the link on the district webpage. It's being overly used by other people that are not allowed to be, well, let's just say, I need to keep the traffic down to a minimum as far as how many people are accessing it. That way the book manufacturers don't come after me.
Website's too popular.
Yeah. So again, it might come to the point where I might have to password protect the documents. If that does happen, I will give you guys logins. Okay? It'll be real easy, but just so you guys know. Okay, that was a pun not intended. Again, to get to the site itself here, sites.google.com, search Mac Murphy DHS. I'll just copy paste it here. Just put it up, then I'll put it in the actual file here.
You know how you get rid of a natural log? You put it in the record. Think about it. No. Just like
There, you can see it better. Let me get this done.